Welcome to section 9.1, part 5. So now we are going to determine the sample size necessary for estimating a population proportion within a specified margin of error. So the setup now is that we would like to know what is the minimum sample that we need to obtain in order to have a specific margin of error. So that means that before we construct an interval, we would like that interval to have a specific margin of error. And if we want a specific margin of error, then we can then determine ahead of time how large the sample size needs to be in order for that margin of error to be that big or that small. Now, to determine the margin of error, there are two scenarios. One where the prior estimate is known, so that means the estimate, which we know is p hat, is already known based on some prior information, some prior study, someone else already talked about maybe the similar topic as we want to find out. So some information is already known. And so we can use a p hat to find the sample size. The formula for the sample size actually comes from the formula for the margin of error. So given a specified margin of error, and of course some confidence level, given a prior estimate, to find the sample size needed, we use this formula. So we use the p hat that we know from the prior study. E will be the margin of error that we want. And the Z, remember that's a critical value based on the confidence level that we want. Now, what if there is no prior estimate? That means we don't have a value for p hat, right? And so if there is no known value for p hat, the p hat that is in use is the average of what a p hat could be. Because remember, p hat can be between anywhere from 0 to 1. So the average will be in the middle, which is the 0.5. So if we punch in 0.5 into p hat into this formula, we obtain p hat is 0.5, 1 minus 0.5 is 0.5, so 0.5 times 0.5 give us 0.25. And that's how this third formula comes from. So when no prior estimate is given, think of it as if you were to be using p hat to be 0.5, and that's where this formula comes from. Now, since n is a sample size, it needs to be a whole number, right? It has to be the number of individuals or objects. So you cannot use like a 0.3 of a person. You have to use the next person. So we always round up. All right. So regardless of which of these two formulas you use, we need the Z critical value based on the confidence level. Okay? Well, there are some Z critical values that we already know about. We know that if the confidence level is 90, then the Z critical value is then 1.645. If the confidence level is 95, then the critical value is confidence level 95, critical value is 1.96. And if the confidence level is 99%, then the critical value will be 2.58. So we don't have to find these ones from scratch all over again if we already know what they are. If you're given something a different confidence level other than one of these three, then you will have to find it from scratch. The other thing that these two formulas need, of course, is the margin of error that is desired. And you will not always be told, oh, we want this margin of error. There are going to be other keywords to tell you that that is the value of the margin of error. And one of those common keywords is within or also just error. Okay? And so that keyword will let you identify the margin of error. Let's look at an example. A sociologist wanted to determine the percentage of residents of America that only speak English at home. What size sample should be obtained if she wishes her estimate to be within 3 percentage points with 90% confidence, assuming she uses the estimate obtained from the Census 2000 supplementary survey of 82.4%. All right, so if we read the problem again, it's asking us for the sample size that should be obtained. That means here the value we're trying to find, or we need to find, is the sample size. So that is the unknown. Right? Let's see what other information we're given. We also know that we want her estimate to be within 3 percentage points. That's going to be the margin of error. So E equals 3%, but we always have to use turn it into a decimal because we're going to punch it into a formula. The other thing we know is the confidence level, which is 90. So based on a confidence level of 90, the Z critical value, so Z sub alpha over 2, is then 1.645. Then the problem also says that she uses an estimate obtained in the census from the year 2000. So some prior information that she has, and that prior estimate is 82.4. So this is the prior estimate. That is a p hat. So 0.824. So if we want to find the sample size and we have a prior estimate, we have a p hat, then we are going to use a formula with the p hat. So we come back over here, right? We're going to use this formula with the p hat because we have a prior estimate. All right, so let's go ahead and write our formula. So our n is equal to p hat 1 minus p hat Z sub alpha over 2, which is a critical value, divided by the margin of error, and then square this. Let's plug in for a number. So p hat is 0.824. 1 minus 0.824. Z is 1.645. Margin of error E is 0.03. Make sure you don't forget to square it. Punch this into the calculator, pretty much the exact same way that you have it written here with parentheses and all. But this is a minus. And we are going to get 436.04. That means 0.04. Sorry, I wrote a 3. That means that this is 436 people and then 0.4 of the next person. Well, that makes no sense. That means you just need the next person. So that's why n is always rounded to the next whole number. So 37. That means that the sociologist needs to obtain a sample size of 437 if she wishes her estimate to be within 3 percentage points with 90% confidence. Let's look at another example. Right, it says if we wanted to estimate the proportion of registered voters nationwide who are concerned about climate change, how many people need to be polled so that we are within 2% of the true proportion with 99% confidence? So this problem is asking us again to determine how many people need to be polled. That means we also need to figure out what is the sample size. Right? The information given is that it says we are within 2% of the true proportion. So that means within 2%, that is going to be our margin of error E. So E equals 2%. In decimal form will be 0.02. And we also want to do this with 95% confidence. So that's going to be the confidence level. I'm going to write it here on the side. So confidence level is 99%. Based on this confidence level, the Z critical value is then 2.58. So this is the information given and also the value we need to find. Let's look at part A. Use a prior estimate obtained from the poll in example. I believe in your notes it's example 3, but it's actually example 4 because it refers back to the problem before about climate change. So that will be example 4. So the prior estimate from example 4. Well, the prior estimate from example 4, so estimate is p hat, was 0.69. So if we want to determine how many people we need to poll using a prior estimate, using a prior p hat, then we have to use that formula for n where there's a p hat. So let's go ahead and plug in. So p hat is 0.69. 1 minus 0.69. Z sub alpha over 2 is 2.58. E is 0.02. Square this, punch everything into the calculator, you're going to get 3,459.51. And remember, we always round up to the next individual, so 3,560. So if we use a prior estimate, then the sample size needs to be 3,560 individuals. Let's look at part B. What if there is no prior estimate? That means there is no p hat. So if there's no p hat, then the formula that we use for n is the one with the 0.25, the one that doesn't have a p hat. So let's go ahead and plug in our numbers. So the z is still the same, 2.58. E is 0.02, so still the same also. Square this, plug it into your calculator, and you're going to get 4,160.25. We round up to the next individual, so this will be 4,161 individuals. So if we don't use any prior estimate, then our sample size needs to be bigger. Now it has to be 4,161 individuals. And this is how we find sample sizes with or without a prior estimate.